On the morning of June 25th, 2026, the ground off the coast of Iwate Prefecture broke for the second time in 8 months. Not a random tremor, not an isolated event. A magnitude 7.2 earthquake, striking almost exactly where scientists had been watching, waiting, and warning that something larger might be building underneath. Prime Minister Sanae Takaichi stood in front of cameras that morning and told residents there was no tsunami concern. Then she told them something else, to remain vigilant for another earthquake of similar size. That warning wasn't caution. It was a signal that Japan's earthquake authorities believe this sequence is not over. 9 people were hurt in Aomori Prefecture that morning. A 90-year-old woman fell and was injured in Iwate. Bullet trains stopped mid-line. And yet, by Japanese standards, this was considered a moderate event, the kind of earthquake the country's infrastructure absorbs and moves past within a day. So why did geodesy experts at one of Japan's top universities respond to a moderate earthquake with visible concern instead of relief? The answer has nothing to do with what happened on June 25th and everything to do with what had already been quietly happening underground for the 2 months before it. To understand why a 7.2 magnitude earthquake made Japan's top seismologists nervous instead of relieved, you have to understand the coastline it happened on. The Sanriku coast runs along the northeastern edge of Honshu, through Iwate and Aomori prefectures, facing directly out over the Japan Trench, one of the most violent subduction zones on the planet. Here, the Pacific Plate is diving beneath the Okhotsk microplate at a rate of roughly 8 to 9 centimeters a year. That might sound small. Over centuries, it is anything but. This is the same fault system that produced the 2011 Tohoku earthquake, a magnitude 9.0 rupture that killed close to 20,000 people and triggered the Fukushima nuclear disaster. It's also the same general region that produced the 1933 Sanriku earthquake, an 8.4 magnitude event that killed over 3,000 people in a tsunami. History here does not move in isolated incidents. It moves in clusters, in cycles, in decades-long buildups that release all at once. Stop for a second and look at the timeline. December 2025, a magnitude 7.6 earthquake off Aomori. April 2026, a magnitude 7.7 earthquake near Miyako. June 2026, a magnitude 7.2 earthquake striking the same stretch of coast again. 3 major earthquakes in the same corridor inside of 8 months. On paper, that could be a coincidence. Earthquakes happen. Japan records thousands of them a year. But the scientists studying this particular sequence don't believe coincidence explains what they're seeing beneath the surface. For the residents of Aomori and Iwate, that history became present tense on April 20th, 2026. A magnitude 7.7 earthquake ruptured roughly 100 kilometers east-northeast of Miyako, sending a tsunami warning across 3 prefectures and evacuation orders to more than 175,000 people. The quake caused only minor injuries. Japan's post-2011 building codes and evacuation systems worked as designed, but something else happened that mattered more to scientists than the damage report. In the government's own words, the earthquake was followed by what geodesy experts call afterslip, a slow, continuing movement along the fault plane that doesn't show up as a sudden earthquake, but instead as gradual, silent motion that transfers stress to the rock around it. The Japan Meteorological Agency raised the odds of a magnitude 8 class earthquake in the following days from a background rate of roughly 0.1% to as high as 1%, 10 times the normal risk. It was the kind of number that doesn't sound alarming until you remember what a magnitude 8 earthquake actually is. Then came June 25th. A magnitude 7.2 earthquake, striking near the same afterslip zone that had been quietly building since April. Tohoku University geodesy expert Fumiaki Tomita told reporters that the accumulated afterslip likely placed new stress directly onto the fault segment that ruptured in June, though he was careful to stress that this connection had not yet been formally verified. The Tohoku Shinkansen bullet train line was suspended for hours. Numerous local train lines in Iwate and Aomori stopped running entirely, with no timeline given for when service would resume. and Japan's Government Earthquake Research Headquarters, which had already been monitoring this stretch of coast since the MW 7.6 event back in December 2025, confirmed what many feared. Multiple quakes have now been occurring in this same area for 8 consecutive months, not settling, not fading, continuing. Here's the detail that should concern anyone following this story closely. After a large earthquake, seismologists generally expect a 10 to 20% chance of another major quake striking the same area within 2 to 3 days. That's standard aftershock probability. Elevated, but temporary, and it fades quickly. What Japan's earthquake authorities are describing here is different. They're not describing an aftershock sequence that is winding down. They're describing ongoing, measurable deformation that has continued for months, well outside the normal aftershock window. That's the detail that separates a routine earthquake sequence from what scientists now consider an active, evolving hazard. Here's where the story stops being about one earthquake and starts being about a much larger structure. The Sanriku coast sits at the southern edge of 2 connected subduction systems, the Japan Trench to the south and the Kuril Trench, sometimes called the Chishima Trench, extending northward off Iwate, Aomori, and Hokkaido. Japan's Central Disaster Management Council has stated plainly that each of these trenches is capable of producing a cataclysmic, maximum-class earthquake roughly every 300 to 400 years. And in late 2025, before any of this year's earthquakes had even happened, that same council released a chilling update. A maximum class rupture along these 2 trenches could kill as many as 199,000 people. That number was published before the April quake, before the June quake, before the current sequence had even started. Now, new seafloor research is showing exactly why officials are so anxious about the Kuril Trench in particular. Using seafloor geodetic monitoring, sensors placed directly on the ocean floor rather than on shore, where signals are weaker and harder to interpret, researchers recently found that the southwestern Kuril Trench has been accumulating what's called a slip deficit for centuries. Imagine 2 rough surfaces pressed together under enormous force, locked in place by friction, unable to slide smoothly. Energy builds at the point of contact instead of releasing gradually. That's a slip deficit. Scientists studying this trench found evidence of 20 to 30 meters of accumulated deficit built up over roughly 400 years. Energy that has never been released in a large earthquake. Their conclusion? This section of the fault is capable of producing a future megathrust earthquake in the range of magnitude 8.8. For comparison, that's more than 11 times the energy of the magnitude 7.7 quake that struck in April. What does that mean for the people living along this coast right now? It means over 175,000 residents across 13 cities, 21 towns, and 6 villages have already been ordered to evacuate once this year. A preview of what a larger event would demand at a much greater scale. It means Aomori, a city of 425,000 people, and Hachinohe, home to over 220,000, sit close enough to the fault to feel the strongest shaking of any major population center in the region. It means Sendai, a city of over 1 million people, 200 kilometers to the south, would still feel a magnitude 8 class event, even if the epicenter itself is hundreds of kilometers away. Think about what those numbers mean in practice, not just on paper. A resident of Hachinohe told local reporters that products simply fell off the shelves of a convenience store during the June quake. An ordinary Thursday morning interrupted in seconds. Multiply that moment by every household, every hospital, every school across 2 prefectures, and you start to understand what a full evacuation of this coastline would actually require. During the April earthquake alone, more than 82,000 households were placed under evacuation orders. That's not a number from a worst-case model. That's what happened from a single magnitude 7.7 event, a fraction of the energy a magnitude 8.8 rupture would release. To put the projected death toll in perspective, 199,000 people is close to the entire population of Salt Lake City, Utah, wiped from a single geological event in a country with some of the best earthquake engineering on the planet, engineering that already worked twice in 2026 and still could not prevent evacuations, transit shutdowns, and injuries. So where does this leave the story right now? In the summer of 2026, Japan's earthquake research headquarters continues to monitor GPS and seafloor sensors across the afterslip zone daily, watching for any acceleration in movement that would suggest the stress transfer is intensifying rather than settling. The Japan Meteorological Agency's elevated risk advisories following both the April and June earthquakes have each expired without a larger rupture, for now. Scientists are careful to say that current science cannot predict exactly when or if the larger event will occur. But the pattern of the last 8 months, a major earthquake in December, another in April, another in June, each one followed by continued deformation instead of quiet, is not something seismologists are willing to dismiss as coincidence. The number they are watching closest right now is aftershock migration, whether the ongoing seismic activity begins creeping northward toward the Kuril Trench segment that has gone silent for 4 centuries. If it does, the question stops being whether Japan's northeast coast will face another major earthquake. It becomes a question of how much energy is left to release and how much longer that segment of the Earth can hold it. Subscribe to stay ahead of what's coming.